So in this video, I'll discuss the chemical bond. Okay? So i-discuss ko dito kung paano na-form yung bond, ano yung properties ng ating chemical bond, and what are the types of bond that exist. Okay? So define muna natin. A chemical bond is an interatomic connection through the valence electrons and valence orbitals, of course. So pwede tayo magkaroon ng mga overlap ng ating valence orbitals, pwede tayo magkaroon ng sharing ng electrons, okay? So those types of interactions are dependent on the nature of the atoms that are involved kapag ka nagbabond. Okay? So, we have some properties. Number one, the bond formation is exothermic. So, ibig sabihin, kapag nag-form ng bond, for example, yung ating A and B, kapag ka nagkaroon ka ng compound AB, tapos may isa siyang bond, magre-release siya ng energy. This is the bond formation energy. Okay? So, if you have the same energy, tapos gagamitin mo naman siya to break the bond AB, okay? Ang energy na yun ay bond dissociation energy. Okay? So, bond dissociation energy is for the endothermic naman, yung kabaliktaran na reaction. Kapag i-break mo yung bond between A and B para ma-produce mo yung individual atoms A and B. Okay? So, the energy of the bonded state AB is less than that of the combination of the energies of the individual atoms A and B. Okay? So, ibig sabihin, kapag ka nag-bond yung A and B, nagre-release siya ng energy, bumababa yung overall energy ng system. Okay? So, mas stable yung bonded state kaysa dun sa mga individual atomic states. Okay? So, formation of a bond makes the system more stable. So, yun yung sinasabi ng number 1. So, for the number 2, the distance between the two nuclei of bonded atoms A and B is called their equilibrium bond distance. Siyempre, meron tayong equilibrium bond distance. Hindi pwedeng masyadong malapit kasi magkakaroon na ng repulsion between the nuclei of A and B. So, masyado na magkalapit yung kanilang center. So, magre-repel na yung mga protons nila. Tapos, hindi naman sobrang layo kasi masyado nang weak yung bond. Okay? Masyado nang magkalayo yung ating nuclei. So, hindi na maaabot ng mga orbitals yung isa't isa. Hindi na sila makakapag-overlap. So, walang bond na ma-form. So, dinidescribe yon ng energy diagram na nandito. So, kapag ka masyadong malapit, masyadong mataas yung potential energy. So, hindi siya ganun ka-stable. So, bumababa yung potential energy habang nare-reach niya yung optimum, which is the equilibrium bond distance. So, kapag nandito ka, optimum yung energy, the bond is stable, tapos meron kang optimum na bond length. Okay? So, the bond length is the length of the bond that is at the equilibrium energy or the optimum energy. Okay? So kapag nilayo mo further yung dalawang atoms, nagkakaroon ka na ng increase again in the potential energy kasi naghihiwalay na sila masyado. Okay? Tumataas na ulit yung energy kasi parang nadi-dissociate na yung bond. Okay? So for the next one, the nature of the compound depends on the character of the bond. So there are 4 possible scenarios kasi kapag nagkakaroon ka ng bond. So again, okay, yung ating mga electrons ay waves. Tinitreat siya as waves in this context. So ibig sabihin, kapag meron kang dalawang atoms na may dalawang wave functions, pagka nagkaroon ka ng overlap ng wave functions na yon, meron kang 4 na possibilities. So kapag nag-bond sila, magkakaroon ka ng parang electron cloud, which is the molecular orbital. Ibig sabihin, yun na yung orbital ng buong molecule, hindi na siya yung orbital ng individual atoms. Okay? Tapos yung location ng mga electrons, nakadepende yon sa nature ng bonded state or yung mga individual atoms pala na A and B. Okay? So, kung mas electronegative si A or ibig sabihin mas mataas yung attraction ni A dun sa mga electrons, mapupunta yung mga electrons sa A. So, yung electron density na tinatawag. Okay? So, electron density is the charge distribution within a molecule or an atom. So, kapag yung charge density mo ay mas mataas sa isang side, ibig sabihin, most probably, nandun palagi yung mga electrons mo. So, ganito yung nangyayari dito sa una nating possibility. So, may possibility na nasa A, halos lahat yung ating charge density or yung electron density. Okay? So, ibig sabihin, for wave function A, nandun yung both 1 and 2. So, kaya siya psi A1 and psi A2. Kasi parehong electrons, mas makikita mo sa A kaysa sa B. Okay? Kasi sa simula, you have psi A, which contains electron 1, psi B contains electron 2. So, kapag nag-bond na sila, yung isang probability makikita natin na nasa A o nasa atom A yung parehong yung majority ng electron density. Okay? So, pwede rin naman mangyari na nasa B yung majority ng electron density. Kaya meron tayong psi B1, okay? Ibig sabihin yung electron 1 nasa psi B, pati yung electron 2 nasa psi B. So, yung psi, again, that's wave function. Okay? So, pwede rin dito, okay, na evenly distributed naman, ibig sabihin yung electron 1 nasa psi A, yung electron 2 nasa psi B or nasa wave function B. So, pwede rin naman na baliktad, yung electron 2 ay nasa psi A, yung electron 1 ay nasa psi B. So, meron tayong dalawang general types ng bonding. So, yung mga bonding na nandito sa taas, sila yung mga tinatawag na ionic terms. Kasi, yung electron density ay nasa isang side lang or nasa isang atom lang. Okay? Kapag shared sila, yung equal distribution, ang tawag doon ay covalent terms. Okay? So, all bonds are orbital overlaps. Tapos may sharing sila ng electron. Yung degree lang ng sharing, yung nagiging parang factor nila. Kung nagiging ionic na sila, polar covalent, or covalent na non-polar. Okay? So, it seems like iisa lang talaga yung type of bond. Nagkakaroon lang ng difference doon sa distribution ng charge density or electron density. Okay? So, ang tawag dyan sa ganyang klase ng addition ng ating orbitals and electrons ay linear combination. Okay? So, linear combination of atomic orbitals. Yan ang ibig sabihin ng LCOW. Okay? Yan yung ibig sabihin ng bond formation. That's linear combination of atomic orbitals. So, in summary, we have kapag binond natin yung atom A and atom B which contains electrons 1 and 2, magkakaroon tayo ng ionic terms which represent the ionic bond. Tapos meron tayong covalent terms which represent covalent bonds. Tapos meron tayong mga tinatawag na coefficients. So kung malaki yung coefficients sa ionic terms, most probably yung compound mo ay ionic. Kung malaki yung coefficients sa ating covalent terms, most probably covalent yung compounds mo. So ano ibig sabihin ng malaki? Malaki yung value. Mataas yung coefficient value. Okay? So, in summary, ionic terms describe an ionic bond character and covalent terms describe a covalent bond character. Okay? So, now we discuss ions and ionic bonds. So, classify muna natin kung ano yung mga ions. So, we have cations and anions. Kapag cations, positively charged ions, mas marami yung protons kaysa sa electrons dun sa kanyang structure. Kapag naman anions, negatively charged ions siya, mas marami yung electrons kaysa sa protons dun sa kanyang structure. So, ions can be single atoms or multiple atoms or a compound. Okay? So, yan ay depende lang sa inyong observation. So, kapag mas maraming protons kaysa dun sa electrons sa kanyang molecular or atomic structure, that's a cation, regardless of what type, kung atom ba siya o molecule. So, kapag mas maraming electrons kaysa protons, regardless of the type, that's called an anion. Okay? So, how do cations form? So, for an atom, kapag nag-apply ka ng ionization energy, yung inyong neutral atom, ma-expel yung kanyang outermost electron. So, magkakaroon ka ng cation, okay, plus a free electron. So, yung electron na yan, hindi na siya attached dun sa inyong atom. Okay? So, syempre, kapag mas mataas yung Z effective, mas mataas yung ionization energy. So, mas mahirap tanggalin yung outermost electron. Pero yung mga metals natin, okay, so sila yung mga mabababa ang ating Z effective. So, therefore, mababa lang yung ionization energy. Mas madaling tanggalin yung kanilang mga outermost electrons. Okay? So, number 1, elements with low Z effective tend to exist as cations. So, sila yung mga metals. So, yung mga metals natin, sila yung mga nasa left side ng ating periodic table of elements. So, meron tayong alkali metals, alkaline earth metals, transition metals, lanthanides, and actinides. So, usually sila ay nag-exist sa mga state na positively charged. Okay? Sila ay madalas na cations. So, for the next one, outermost electrons, specifically electrons of highest n or yung pinakamataas yung kanyang principal quantum number, sila yung mga unang na-ionize. Okay, so for example, aluminum. So since yung pinakamataas na occupied shell ng aluminum ay nasa n equals 3, so we have 3s2, 3p1. So for the first ionization, ma-ionize yung 3p bago yung 3s because the 3p has higher L value. So magkakaroon ka ng 3p0. So that's aluminum plus. So further removal of the electron will require a lot more ionization energy. So mas mataas yung second ionization energy kaysa sa first ionization energy. So kapag i-remove mo na yung electron dun sa 3s orbital, magkakaroon ka ng 3s1. So magkakaroon ka na ng Al2+. Okay? So for the next one, we have manganese. So manganese has an electron configuration of argon 4s2, 3d5. So for the first ionization energy, since mas mataas yung n equals 4 kaysa sa n equals 3, mauunang matanggal yung electron sa 4s. Okay? So kapag sa second ionization, matatanggal na rin yung isa pang electron dun sa ating 4s. So kapag further ionization, tsaka palang matatanggal yung electron dun sa 3d. Okay? So next, we have cerium. So sa cerium, the electron configuration is xenon, 6s2, 4f2. Pwede ring 6s2, 5d1, 4f1 in some literatures. So after the first ionization energy, ang ma-ionize ay yung nasa 6s na electron kasi siya yung pinakamataas ang N. So, mangyayari, magiging 6s1 4f2 or yung 6s1 5d1 4f1 for Ce+. Okay? So, after the second ionization energy, yung 6s electron pa din yung ating ma-ionize. So, magkakaroon tayo ng Ce2+, where the electron configuration is 6s0 4f2 or just 4f2. Okay? So, pwede ring xenon 6s0 5d1 4f1 or just xenon 5d1 4f1. So, further ionization, kapag dito, ma-ionize na natin yung 4f electron, pero kapag dito, ma-ionize muna yung 5d na electron. So, dalawa yung configurations na pinakita ko kasi magkakaibang configurations yung pinapakita ng iba't ibang literature. Okay? So next we have the formation of anions. So paano sila na-form? So from a neutral atom na may mataas na effective nuclear charge, magka-capture siya ng electron, okay? Magkakaroon ka ng anion and magre-release siya ng energy in the form of your electron affinity. So kapag ka mas mataas yung effective nuclear charge, mas mataas yung nare-release niyang electron affinity. Okay? So yung may mga matataas na effective nuclear charge, they tend to exist as anions. Okay? So madalas ang mga ganitong element ay mga non-metals. Okay, so kung ang metals sila ay madalas mag-form ng cations, yung mga non-metals naman na may matataas na C-effective, sila naman yung nagiging anions. Okay? So, paano nag-enter yung electron? So, the entering electron enters the atom according to the Aufbau principle. So, kung ano yung may available na orbital na may mataas na n plus L, doon lang mapupunta yung ating entering electron. Okay? So, for example, oxygen. So, for the oxygen, we have the electron configuration helium 2s2 2p4 since hindi pa fully filled ang ating 2p or 2p orbital. Kapag naglagay ka ng electron, additional electron, magkakaroon ka ng O- which is a configuration of helium 2s2 2p5. So kapag naglagay ka pa ulit ng isa pang electron, magkakaroon ka ng O2-, okay, which is the oxide, which is an electron configuration of helium 2s2 2p6. So yung electron affinity nito ay mas mababa kaysa sa electron affinity na una, or yung first electron affinity ay mas mataas kaysa sa second electron affinity. Kasi putting electrons in anions, okay, are more difficult than putting electron in a neutral atom. So mas mahirap maglagay ng electrons sa isang anion kaysa sa neutral atom kasi anion na siya. Mas mahihirapan ka na maglagay ng negative charge sa anion. So mas mababa yung napoproduce niyang electron affinity. Okay? So another example, we have phosphorus. So phosphorus has an electron configuration of neon 3s2 3p3. Since hindi pa fully filled ang ating 3p orbital, kapag naglagay ka ng electron, dyan lang siya mapupunta. So yung p minus mo magiging neon 3s2 3p4. So kapag naglagay ka pa ulit, dun siya sa 3p orbital mo ilalagay. So yung p2 minus mo magiging neon 3s2 3p5. So finally, kapag naglagay ka pa ulit, this phosphide is neon 3s2 3p6. So magiging isoelectronic na siya sa argon. Ito naman ay isoelectronic sa neon. So may mga noble gas configurations na sila. Okay? So kung meron na tayong anion and meron na tayong cation, paano naman na-form ang inyong ionic bond? Okay? So ionic bond forms through electrostatic attraction lang. So since ito ay positive, ito ay negative, so magkakaroon ka lang ng electrostatic attraction depende dun sa magnitude ng charge nila. Okay? So kapag na-form ang inyong bond or ionic bond, nagre-release siya ng energy. So this is the first feature of our bonding. Okay? All bonds produce energy upon formation. So this is the bond formation energy. Okay? So kapag na-forming inyong ionic bond, there will be a severe charge separation. Kasi meron kang anion, so nandito nakakoncentrate yung electron density na tinatawag. So yung electron density, that's the probability of electron location. So kapag mas mataas yung electron density, ibig sabihin mas mataas yung probability na mahanap mo yung electron sa area na yon. So yung mga regions sa pinakamatataas ang electron density, doon mas namamalagi ang inyong mga electrons. So ibig sabihin kapag yung sa anion, doon namamalagi yung mga or yung most ng inyong electrons doon sa bonding. So kaya negative yung kanyang charge and mataas ang kanyang charge density. So wala masyadong electron density dun sa cation, okay? Obviously because of the difference in their Z effective. So mas mataas yung effective nuclear charge ng anion kaysa sa cation. Kaya most of the electron density ay nasa anion. Okay? So for the standard measure of the energy of a certain ionic compound, we have the lattice energy. So the lattice energy is the energy released when an ionic crystal forms from its constituent gaseous ions. So dapat yung ions nyo dito ay gaseous. That's the standard measure. Okay? Hindi kasi natin ito matatawag na lattice energy because hindi natin in-specify yung state ng ating cation and anion. They can be solid, liquid, or gas. Okay? So hindi natin na state. So this is just the generalized bond formation energy. So yung bond formation energy, pwede siyang maging formation energy ng ating covalent compounds, ionic compounds, etc. So it's just a general term for the energy released when bonds are formed. Dito, meron na tayo specific na energy for ionic compound formation. So ang na-form ay yung solid na ionic compound from the gaseous ions, Cl- and sodium+. So para makita nyo yung charge ng Cl, buburin ko lang to. Okay, so makikita nyo na gaseous chloride and gaseous Na+ yung nag-combine para ma-form yung NaCl. Okay? So the next type of bond is called the covalent bond. So ang covalent bond, mas nasi-share niya yung electron density sa mga atoms na involved sa bonding, hindi tulad ng ionic bonds na may severe charge separation. So sa ionic bond kasi, nako-concentrate lang yung charge or yung electron density dun sa mas electronegative na anion. So dito, okay, hindi ganun ka-severe yung charge separation. Wala tayong makikitang positive and negatively charged ions dito. So, ano sila? Molecule sila na neutral yung charge pero may konting distribution lang or difference in the distribution of electron density between the atoms. Depende dun sa difference nila sa Z effective. Okay? So, we have two types. So, ililimit lang muna natin yung discussion sa mga diatomic molecules. So, diatomic molecules are molecules with two atoms as their members. So, dalawa lang yung atom sa diatomic molecule. So, meron tayong dalawang types. So, we have, number one, the homonuclear. Ibig sabihin, they have the same atom. So, kung pareho ng atoms, pareho siya ng Z effective. So, therefore, kapag nagkaroon sila ng bond, the charge distribution or the electron density distribution is uniform. So, pantay na pantay ang ating charge distribution. So, ang example nito ay mga helium-2, F2, Cl2, lahat ng diatomic molecules na same atom or homonuclear. Okay? So, the second type is heteronuclear. So, ibig sabihin, dalawa yung atom or dalawa yung types ng atom na nandun. Okay? Magkaiba silang atom. So, the effect in the Z effective is noticed kasi makikita nyo doon sa resulting na bond na mas nakukuha or mas nakakalamang yung isang atom sa electron density kaysa dun sa isa. So, yung isa na may mas mataas na effective nuclear charge, siya yung nakaka-experience ng mas mataas na electron density kaysa dun sa isa. Okay? So, the charge distribution favors the one with more effective nuclear charge. So, ang ibig sabihin kapag mas mataas yung electron density sa iyong side or nagfe-favor sa iyong electron density, ibig sabihin, you are the one that is more electronegative. Okay? So, what is electronegativity? So, electronegativity is a measure of the ability of an atom to attract electron density in a bond. So, the more electronegative your atom is, the more pull it exerts dun sa inyong electron density. Mas napupunta sa kanya yung electron density. So we're talking about electron density. That's the measure of the electron's most probable location around an atom or a compound. So kapag mas mataas yung electron density mo sa isang atom, mas mataas yung probability na nahandon yung iyong electron sa atom na yon. So yung charge nung certain atom na yon ay more negative. Okay? Kasi mas nalolocate mo doon or mas nag-stay doon yung electrons. Okay? So, higher electronegativity, higher tendency to attract electron density. Electronegativity, by the way, is related to the effective nuclear charge. So, kapag mas mataas yung effective nuclear charge, mas mataas ang electronegativity, mas mataas ang pull niya ng electron density. Okay? So, ito yun. So, meron tayong measure ng electron density or electronegativity. Okay? So, we have the Pauling scale electronegativity. So, this is a relative measure of electronegativity based on Pauling's or Pauling's method. Okay? So, meron tayong formula ni Pauling kung paano na-determine yung Pauling scale electronegativity. Pero hindi natin i-discuss yun. Ipapakita ko na lang sa inyo yung values. Okay? So, paano niya nakakalculate or paano natin nakakalculate yung difference in the electronegativity and paano natin nakaklasify yung compound based on this difference. So, the change in the electronegativity or the difference is calculated. Okay? So, kapag ang difference in the electronegativity is less than or equal to 0.4, the compound is so-called non-polar. So, may polarity siya pero it's very negligible. Okay? Kasi meron pa namang difference pero hindi na siya tinatawag na polar compound kasi sobrang baba na ng value. Pero kapag yung electronegativity mo ay between 0.4 and 2.0, ibig sabihin greater than 0.4 pero less than or equal to 2.0, that's classified as a polar compound. Kapag naman greater than 2.0, kinaklasify na siya na ionic. So, ibig sabihin, masyado nang mataas yung difference sa electronegativity. Okay? Tinatawag na siyang ionic compound. So, tendency nun, ions na sila kapag ka nag-bond. Okay? So, for example, we have the CH bond. So, CH bonds are usually found in organic compounds. So, the difference in electronegativity is 2.5 for carbon. Okay? Tapos, 2.1 for hydrogen. So 2.5 minus 2.1 is 0.4. So the CH bond is technically considered non-polar according to the Pauling scale electronegativity. So yung OH naman, tingnan natin yung OH. So oxygen is 3.5, hydrogen is 2.1, that's 1.4. So ito yung criteria. So the OH bond is considered as polar. It's strongly polar kasi it's mas malapit siya sa 2.0. Okay? So yung NaCl, tingnan natin. So Na is 0.9. Okay, Cl is 3.0, so 3.0 minus 2.9 is 2.1. So according to the Pauling scale electronegativity value, the compound is ionic. So NaCl is an ionic compound. Okay? So another type of bond is called the metallic bond. Okay? So metallic elements often share their valence electrons and orbitals due to the low values of their effective nuclear charge. So kapag may dalawa kang atoms at nagdikit sila, automatically nasi-share nila yung kanilang valence electrons and orbitals. So kapag marami kang metallic atoms na nagsama-sama, nagkakaroon ka ng ganitong klase ng structure. So around the metallic structure, meron kang electron cloud. Okay? So yung electron cloud na yan, lalo na kapag single metallic atom lang yung pinag-usapan natin, okay, evenly distributed siya throughout the whole metallic structure. So, electrons are delocalized. Ang ibig sabihin, yung electron nyo ay distributed evenly throughout the whole metallic structure. Hindi siya nalolocalize sa isang atom lang. So, it's delocalized around the whole material which serves as a glue which holds the atoms together. So, yung parang coating na yan ng electron, yan yung dahilan kung bakit yung mga metals natin ay ductile and malleable. So, it's like a glue-like structure na naka-embed doon yung kanilang mga atomic nuclei. Okay? So, nagkakaroon siya ng certain ductility and malleability. Okay? Kasi yung electron cloud na yan ay medyo soft. So, yung mga metals natin ay very dense, okay? But they are soft. So, metals kasi ay maliliit lang na atoms due to the usually the transition metal contraction, for example. So, lumiliit yung kanilang atomic radii. Okay? So, madalas din yung polarizability nila ay matataas, okay, because they are at the left side of your periodic table. So malalambot lang yung kanilang mga electron densities or mga electron clouds. So nagkakaroon ka ng ganitong mga resulting material properties. So the free movement of electrons around the material explains the high electrical and thermal conductivity of metals. Since delocalized yung electron, freely moving siya around the structure. So kapag nag-pass ka ng current, so walang obstruction yun kasi nakakapass siya through the orbitals that are shared by all the atoms of your metal. Okay? So finally, we have the classification of matter. So this classification is based on bonding type. So for the first one, we have ionic compounds. So yung ionic compounds, okay, they are continuous structures. Ionic compounds can extend infinitely at all directions. So, pwede ma-extend yung structure na yan basta meron kang enough amount ng positive and negative charges or cations and anions. Okay? So, ionic compounds are non-conducting in its solid form. So, hindi kasi masyadong gumagalaw dyan yung mga ions. So, hindi siya masyadong nagko-conduct ng electricity. Actually, hindi talaga sila nagko-conduct ng electricity kasi naka-steady lang dun sa locations nila yung mga ions or yung mga cations and anions. However, kapag minelt mo sila, nagmo-move na yung mga ions. So, moving charges allow passage of electricity. Okay? So, these compounds are very hard and brittle. Kasi, halimbawa, if you have this structure, okay, kapag inurong mo yung positions ng positive and negative charges, magkakaroon ka ng electrostatic repulsion. So, very sensitive dun sa location yung mga ions. So, matitigas sila because of electrostatic attraction, pero kapag na-move yung structure nila, mabilis silang nababasag or they are very brittle. Okay? So, they also have high melting points, okay? Kasi because of the electrostatic attraction. Maglalakas ang electrostatic attraction. So, mahirap silang ma-break. Okay? So, next, we have the metallic compounds. So, metallic compounds, again, na-discuss ko na kanina, they are continuous structures. They can extend infinitely, okay? As long as you have enough atoms na of the same metal. Okay? Pwede ring different metal, basta nag-agree siya dito sa mga properties ng metallic compounds. So, Metallic compounds are conducting in its solid and molten form kasi the delocalized electrons allow passage of electricity. Tsaka ina-allow din siya ng mga valence orbitals ng inyong metallic compound. So, metallic compounds are soft, malleable, and ductile due to the electrodelocalization structure, yung parang glue-like structure around the metallic structure or the metallic compound. Okay? So, mataas ang density nila and matataas din ang melting point because metallic bonds are very strong. Okay? Tapos, ang mga metals din ay very strongly held by their overlapping orbitals. So, mataas ang kanilang melting points and density. Okay? So, proceed naman tayo dun sa covalent molecular compounds or the so-called molecules. Ito actually yung tinatawag nating molecules. Okay? So, covalent molecular compounds are discrete structures. Ibig sabihin, nag-exist sila independently. Hindi sila pwedeng ma-extend. Okay? So, tulad ng CO2, water, and ammonia. So, meron silang mga discrete structures na hindi nagpo-form ng continuous lattice like yung inyong ionic compounds and metallic compounds. Okay? So, nag-vary yung kanilang mga properties kasi iba-iba yung connectivities ng inyong mga covalent molecular compounds. So, heavily dependent doon sa mga properties ng mga individual atoms involved yung magiging property ng inyong covalent molecular compounds. So, nag-vary din yung melting points and boiling points. So, pwedeng solid, liquid, or gas ang inyong covalent molecular compounds. Again, because of the variations in their discrete structures. So, ayan, other material properties may vary. So, maraming covalent molecular compounds. There are millions and millions of compounds, okay, na may iba't ibang properties. So, finally, we have the covalent network compounds. So, they are also held by covalent bonds, pero they are continuous structure. Okay? So, this structure is the structure of the diamond kasi it's a carbon that is connected to 4 other carbons tapos nagko-continue yung structure na to all throughout the diamond structure. So, continuous structure sila. Ibig sabihin, they extend infinitely at all directions. Tapos, they are non-conducting kasi wala naman silang freely flowing electrons, wala silang freely moving electrons, wala rin silang charges. So, kahit i-melt mo to, hindi pa rin sila magko-conduct ng electricity. So, sometimes they have semiconducting properties, lalo na yung inyong graphite, because graphite has a free p electron or 2p electron. So, yung 2p electron na yon, medyo na-delocalize siya doon sa inyong graphite structure. So makikita nyo sa graphite or sa graphene na meron tayong semiconductivity. Hindi ganun kataas yung conductivity niya, pero meron tayong value ng conductivity. Pero hindi ganun kasing taas or hindi kasing level ng conductivity ng mga metallic compounds. Okay? Medyo mababa pa rin. Tapos meron silang matataas na melting point because of the continuous structure and the strong covalent bonds. Tapos they are very hard. So they are very hard and their brittleness is less than that of the ionic compounds kasi hindi naman sila ganon ka sensitive sa kanilang position. So pwede sila mag-break pero hindi sila nadudurog agad tulad ng mga ionic compounds. Okay? So ang susunod kong discussion after this video is yung valence bond theory and the valence shell electron pair repulsion theories to describe the overlap of orbitals and the geometry and polarity of the resulting molecules. So see you next video.